So let's open this first presentation right here, which covers the idea of streams, and some of these topics were already discussed. So again, when we're discussing streams, at least in programming world, I envision the presence of these character buffers, or memory buffers in computer memory when I work with those things. So basically these two, this and this, those are the examples of the two things that I envision when somebody tells me about the stream. So the areas that fall under the category of streams includes input stream and output stream devices, standard output such as this, and standard input and formatted input output is something that we're going to discuss in detail. The way the streams are available to be used in C++ program is what I already tried to do here. Is basically just by choosing correct standard library headers, we are provided with access to facilities in the library, and of course we have our device drivers that are part of the operating system that manipulate the actual physical devices. So formatted input-output, generally speaking, refers to plain text, and type safety, the key attention to type safety in C++ is also addressed through manipulation of in formatted mode or using formatted input-output. Unformatted mode uses byte-by-byte operations and, generally speaking, doesn't care about individual data types. You have to make your own choices, and you have to make your own decisions to how to manipulate these individual bytes and what to do about them. So the examples of input-output devices such as character output. The type of the cout is O-stream. Okay, so this is the type in standard library with which defines the type of this object. So this is an object memory which holds on to this buffer somewhere in memory, and its type is this. And character input type is std istream, O-stream and istream, input stream, output. And these are the same way, right? Same type. These are all output streams, and they're all falling under this category, output stream. So we can separate out the input stream as a separate category, but these are all the same type. They're just attached to different devices or to different files, but in general, they're the same type. And we say here in our presentation that C++ stream library is extensible. You can define your own input-output operation for your own types. So that's one thing to do. But additionally, like I told you, the same approach is used, the same kind of approach is used for working with both files and keyboard and screen output. And initially, when the program just is starting, typically by default, the cout, cerr, and clog are all attached to the console output device, and the syn character input device is attached to the keyboard. But those things can be manipulated differently, and they can be reconnected with the different programs or different devices. We'll probably try some examples of that as well today. All right, so what else? So this is the example of that memory buffer that I was talking about. Basically, this is our program. We're trying to communicate with the character output. Character output is managing memory buffer. Eventually, this memory buffer becomes available to the operating system, and the device driver, which is responsible for physical communication with the device, takes information from memory and somehow delivers it to the output device. So the output device makes it visible somewhere, right? So that's the idea how this communication is structured between our program and the final device that actually displays the information. Now, character output, its responsibility as a helper object for us is that this automatically converts integers and doubles and booleans and text into appropriate sequences of characters in this memory buffer, which becomes ready for display on the output device. And we already mentioned that this object can also be reattached. I mean, specifically this memory buffer can be communicated to both devices and files, so which is very important for us, provides us with a lot of flexibility, right? So another picture of this memory buffer, the concept is that we take cout and we use the output operator and we say hello. We can send individual characters and we can also send integers to the output. And all of this gets converted into some sequence of characters or bytes in this memory buffer right here somewhere, which is managed by this object in memory. And eventually this becomes visible on the screen. The input stream concept should be very similar, right? Again, there is an input device, which is a physical device, which is controlled by the operating system, specifically the device driver that works with this input device, so it knows how to communicate with the device. And we provide it with the memory buffer, which it is using to populate it with information. For instance, this could be a keyboard, so we populate it with information, and eventually character input device SYN gets to this memory buffer and knows how to convert this data back to internal data types like integers and doubles and other types that we can use, right? So input stream, and the type of this device is input stream, as we mentioned, turns character sequences into various data types, and this place input device can be a console, keyboard, could be a file, could be another part of memory, or even another computer, which means that we could be using a network connection over here to read the information from another computer when we have a network connection to it. But eventually our program will get this data just fine. So this is, again, the idea of the input stream buffer is that we try this program. First of all, we provide again, this is a demonstration of formatted input. And with two integers, I have created two integers, 1 and 2, and I'm using the standard input like this. And I am simply connecting this and this. This is my variable. This is my input device. I'm connecting it by this operator. And magically, whenever this information becomes available in a buffer, I told you that the user eventually hits enter, and this is the signal to the system to actually process this. And the user is typing individual characters 4, 5, 6, but very likely this will be converted to 456 value inside my integer when the character input device gets to process. So that's the idea. And I mentioned already that The nature of stream processing and the power of simplicity and its power uh, essentially becomes a foundation for network communication, encryption, data compression, like archived files or folders which are being compressed to a smaller size. Both compression and decompression is processed by the stream approach. Persistent storage of objects is another example of this of the stream processing. For example, you can take object in memory, convert it to a sequence of bytes, and save it in the file. Later, be able to load it right back. And very possible that just plain vanilla character oriented input and output we may be doing by using streams.